Okay, welcome back. It is day 100, nope, 203 of coding every day. Um, did in fact code today, but like I said, every Friday I'm just going to go over what I did for the week in terms of the coding I'm doing for my research. Um, so yeah, I guess before I get into the slides, today particularly, um, obviously presented this what I'm about to show this morning, and then um, worked on honestly tried to work on the actual hardware of trying to send packets and receive them. No idea what's happening with that. Not working at all. Don't even know. Like I'm just installing random stuff that ChatGPT is telling me to install and trying to just force run it. And yeah, so I'm gonna need a blank mind this weekend, and I'm gonna try to tackle that stuff this weekend. Um, but yeah, so maybe I'll even do that for videos this weekend. Um, but but yeah, other than that, not much happened today. Um, so yeah, so a recap of this week for my research. I had to export this from like Canva to Google Slides, so that layering wasn't in the actual whatever. Um, but so this week I worked on doing movement detection using Wi-Fi radio frequencies. So the project that I'm working on is like a 3-year project, and we're the first people working on it. So they want us to do everything in simulation and get like kind of a system design, kind of an overview of what this uh, smart home is gonna like look like, so that they can implement it. Um, you know, probably next year. And so the thing is my partner is working on camera input, so like a live camera feed that is able to detect certain types of movements from people with ASD, and then classify those movements and then change the environment um, based on that. And so that is quite intrusive, especially in a home. In a community, more professional setting, like a clinic, that's a lot more acceptable. But there's a lot of people that do not want just a camera in their room, tracking their every movement and like recording them, especially if you're going out to the cloud with this, like with information at all and being exposed. It's in no like edge computing, it can be a little scary. So the idea here and what I was working on, um, is the idea is you're able to, hang on, let me take a step back. So say you have a router and the router is constantly sending packets out. Say they're just empty packets, there's no like real payload. Those waves go through the room, some go through the walls, some get reflected by the walls, some get absorbed by the walls. You send out about like 30 different frequencies within, actually technically it sends out like 64, or it depends on like the sender, but say there's 64 channels of different frequencies because Wi-Fi is wideband. Um, all those radio waves are going out throughout the room and bouncing and reflecting. And the amplitude, which is, let's say it gets sent out at 1 volt sine wave, right? It'll get received at maybe zero point zero 0.02 or 0.23, or something along the lines of not one, if that's what you're sending out as the power, which I don't know all the metrics of that stuff, but somewhere between that and like an amplitude of 0 is where it will be. And so if you have someone that now walks through the house, like let's say you get like a baseline of all the readings and you like zero it out, right? Like all the waves are propagating around the room and bouncing off furniture, and you get that for like a long time series. You can kind of see how the room is and how everything bounces around without any movement. So that can be your baseline. So like on this graph, these like low points are kind of baseline. And so this first section was me just moving through the room, and so the amplitude changes. It could go up or down. The reason why on this graph it only goes up is because in simulation, I can't simulate radio waves because it's way too computationally expensive. So I'm just firing off a few hundred to like a few thousand raycasts that on interval keep firing to keep collecting data on path like um, collision, and if it hits the character, it scatters and creates more rays, and so that way the amplitude will go up when they're walking through because more rays are being formed. Now, obviously, this isn't replicating of real life because you can't just form more energy off of bouncing off something. It's just how I'm right now being able to record not using radio frequency. Um, but the idea is you'd be able to move through a home environment and the amplitude would change. And based on that change, the change is more so like waves. So let's say you're flat, no movement. And when you start walking, the waves might be like this. Now, let's say you start flapping your hands. Maybe it's like this, like the waves are a lot more fast. Um, and you can just train a model on all these different labeled datas of like flapping arms or running or pacing or walking and all these movements, even as minuscule as like a hand waving, something very like minute can be trained and detected because these waves are very sensitive. So that's the whole idea behind this. So moving forward after this week, so this whole week was working on the simulation and getting all this like set up in a way that kind of mimics real life, um, and just getting and setting up like animation and whatnot in my home and colliders on that like character. Up next is actually finishing my idea for this and how I want to capture this information in simulation, and then collecting that data, being able to make a autonomous simulation of a character being able to run around a room, walk around, whatever, and do multiple different types of ASD like movements, whether it's hand flapping or pacing or hitting or whatever it may be. And then it would automatically label whenever the random animation is turned on. So then I could have CSI information of amplitude changes within the room, and then I can map those to the labels, and I pass it through a CNN. It tries to automatically label, compares to the actual labels, whatever, the whole model training method. And then at the end, I should be able to have a model that I can just plug in to the actual home, and based on real time me being a user, like just doing random ASD movements going around, it should be able to detect that and change the environment based on how I feel right now would be fit for someone with ASD. So, um, and then integrating, like I just said, integrating that into the IoT system. And I just want to work more on that IoT system and trying to get like network delays or packet loss or whatever to make it just feel more real and be able to be mapped to the actual um, map it to the actual real home that they'll be setting up in the like next year or so. Um, so yeah, that was my week basically. Um, Next week, I think it is just gonna be this whole CSI data collection, and just mainly that, and on like the side, I'll be working on like the IoT upgrades of like delay and packet loss and trying to just make that whole system more realistic. So, but yeah, that is all I have for today. I will see you tomorrow, which, with what I said, probably working on that hardware, which could be pretty cool, or just another leak code if I don't end up sharing that. So, okay. Take care. I'll see you tomorrow. Bye.